This is a lecture on 9-4, testing the difference between proportions. So at this point, this is probably the ugliest of all of the formulas in hypothesis testing. What we're doing is we are hypothesizing about a population proportion. So let me start with the null and alternative hypothesis. It is P1, it is P1 equal to P2 for the null hypothesis, and a P1 not equal to, maybe less than or greater than, P2. So just like your two sample tests, you have to figure out which sample you're going to call sample 1 and which sample you're going to call sample 2. Remember that every single time your P1 is going to be minus P2, so P2 is subtracted from P1 for these tests. So when you're looking at this less than or greater than, make sure that you assign the right one in the right place. But in the calculator, it'll always do P1 minus P2. So if you see any negatives pop up, it just means that whatever you called sample 1 is smaller than whatever you called sample 2. The formula is a 2 proportion Z-test. For the same reason as before, it is a binomial setting. Binomial distribution can be well approximated with normal distribution if those n's are large enough. So what this means is now you have to do this a couple of times. You need to make sure that n1 p1 is greater than or equal to 5, n1 q1 is greater than or equal to 5, and then you have to do the same thing for the second sample. So n2 p2 is greater than or equal to 5, and n2 q2 is greater than or equal to 5. So there's more stuff to check. A test statistic is a z. And is given by P1 hat minus P2 hat. So you'll find those hats and you can find the difference. Minus P1 minus P2, so your hypothesized difference, that one should be a 0. But on the bottom, you have something called a P bar and a Q bar. And then you multiply this by 1 over N1 plus 1 over N2. Now, the formula has more stuff in it because, well, P1 hat and P2 hat, that's pretty self-explanatory. You just take the ratio of basically however many people said yes to your question divided by how many people you asked. And same thing for the sample, for the second sample. Now P bar is something that they called P bar, and it's one more formula that is embedded within the test statistics. So all of these formulas are programmed into your calculator. I just want you to have a feeling of the appreciation of the calculator at this point. So the Q bar is then found by 1 minus P bar. So what they're doing is they're looking at a really funny way of looking at the average between the two proportions. So all of this is calculated under the test statistic, under your two proportions Z-test. So at this point, we can take a look at the first example that is in the book. The example that I'm looking at is example 9-9. So let me start reading this. In a nursing home study, the researcher found that 18 out of 34 randomly selected small nursing homes has a resident vaccination rate of less than 80%, while 17 out of 24 randomly selected large nursing homes had a vaccination rate of less than 80%. At alpha of 0.05, Testa claimed that there's no difference in the proportions of the small and large nursing homes with a resident vaccination rate of less than 80%. So note number one, this word of resident vaccination rate of less than 80%, this has nothing to do with the problem besides the fact that this is your what's called success. So resident vaccination rate of less than 80%, this is your success. Okay, so what we need to figure out is what is my sample 1 and what is my sample 2, and an x and an n with respect to each of the two samples. So what we're doing in this problem is we're looking at small nursing homes. I'll call this sample 1. And I have large nursing homes. This is my sample 2. So in the first one, I'll call this N1. They went out, they studied small nursing homes, and they studied 34 small nursing homes. And within each nursing home, they were looking at the number of people who were vaccinated. Now, if it's less than 80%, they put 1 under success. If it's over 80%, they put 1 under failure. So what they did is they actually counted 12 of those successes. In the large nursing homes, they went out and they only studied 24. And they found that 17 out of those 24 nursing homes had a vaccination rate of less than 80%, meaning people in generally not vaccinated. This is it as far as writing down the necessary statistics. What I'm doing is I'm running a two proportion Z-test. And I need to set up my null and alternative hypothesis. The null hypothesis has to be P1 is equal to P2. Now the alternative hypothesis, I'm going to be looking for, there is no difference in the proportions of the small and the large nursing homes. So this suggests that I'm talking about a two-tailed test. So I'm running a two proportion Z-test, two-tailed. In order for me to be able to run this test, I will check the necessary conditions. So my P1 hat will be 12 out of 34. If you want, you can write this down as a decimal. A approximation is fine because all we're doing is trying to get the conditions ready. The P2 hat is 17 out of 24. That's about 71%. So what I need to go through is a series of condition checks. So N1 times P1 hat is 34 times 0.35 That's about that should come out as my 12, give or take. My N1 Q1 hat is the 34 times the other 65%. Approximations are perfectly fine because all I'm looking for is just that this number is greater than or equal to 5. Do the same thing for the other one. You have N2 times P2 hat. So you have that 24 times 0.71. Have about 17 people, so that's greater than 5. And 2P, no, not P, Q hat, that's 24 times the rest of that that 0.71, so that's 0.29. 24 times 0.29, we're at about 7. Just barely made it. So n is equal to 24 is a really small number to be able to analyze a proportion. Just barely made it through the conditions of even running this test. Now that we know that we can run this, we click Stats, go over to Tests. What you're looking for is a 2 proportion z-test. It's going to ask you, what is your x1 12, n1 34, x2 17, n2 24, and it's going to ask you two-tail, left tail, right tail. In this case, it is a two-tail test, and just push enter. It's going to spit out some interesting information. Z is equal to negative 2.666, so I'm going to write this as a 67. The p-value came out as 0.0076, so I'll say that as an 8. This is a really small number. They did give me an alpha of 0.05, so I can go ahead and compare. Well, less than 1% is certainly going to be smaller than whatever alpha that they're going to pick. They said 5, great. So if the p-value is less than your alpha, you do reject the null hypothesis in favor of the alternative hypothesis, and the alternative hypothesis that there is a difference between vaccination rate between small nursing homes and large nursing homes. So enough evidence to suggest that there is a difference in vaccination rate between small and large nursing homes. My second example is, can I find the confidence interval using the same data? The formula of finding the confidence interval is going to be so long that I won't be able to fit it on this page. So my suggestions is, if you want to take a look at the formula, it's on page 523. It is pretty ugly, and I don't want to write this down on my notes. It is calculated, so the formula is calculated under your 2 proportion z interval. 2 proportion z interval. So what you're going to do is you're going to go into stats, go over to tests, click on the two proportion Z interval, and all of the numbers should already be there. If we want to do a 95% confidence level, you adjust your 0.95 and calculate. What it gave you is a negative 0.598, comma negative 0.1128. So notice both numbers are negative. Both numbers negative suggest that enough evidence to suggest, and I'm really reading what I have on the top. So both negatives means that I do reject the null hypothesis. Enough evidence to suggest that there is a difference in vaccination rate between small and large nursing homes. In fact, I actually know what the difference is. The first one is smaller than the last one. So my first one had that was the small nursing homes, and they're not as good as the large nursing homes in vaccination. They're the people who occupy them. So the data suggest that small nursing homes have lower vaccination rates than large nursing homes. By about, and you see this is a 60%, this is 11%, by about 11% to up to 60%. If you have any questions on how to enter this in the calculator, please ask me in class. I will not do this on a calculator in the next example because all of the buttons are already well familiar with. You're well familiar with. This is the end of chapter 9, and we will start with chapter 10 in the next videos.